Hi, I'm Jamy Lee. I'm an assistant professor at the University of Twente. I'll be presenting on-road and online studies to investigate beliefs and behaviors of Netherlands, US, and Mexico pedestrians encountering hidden driver vehicles. 22% of traffic fatalities are pedestrians, according to the World Health Organization. It's an important issue to understand how pedestrians will interact with future autonomous vehicles. Since getting a real autonomous vehicle is hard, Rothenbucher demonstrated how to use a normal vehicle driven by a human ghost driver, who's a person hidden in the car seat costume, to simulate an autonomous vehicle. This method was first used in California and has since been used in Mexico and online. We asked, is this method reproducible in Europe? And is it measurably reproducible online? We also wanted to extend the hidden driver Wizard of Oz method by looking at three things. First, what features influence how much people believe a hidden driver vehicle is autonomous? The Wizard of Oz method is common in HRI, but past work has only looked at whether a futuristic appearance of a car results in higher belief that it is autonomous. How much do other features, like the presence of LiDAR, cameras, or the absence of a visible human driver, matter for perceptions of a car's autonomy? This could help HRI researchers understand what cues can best create a believable Wizard of Oz system. Second, what pedestrian feelings, such as feelings of concern for their safety or feelings of interest in a vehicle, are associated with atypical behavior with autonomous vehicles? Third, how do groups of pedestrians behave compared to single individuals when encountering an autonomous vehicle? To answer these questions, we conducted two studies. First was a field study with 130 people. We followed the same procedure as the original Rothenbucher study, except that we added a normal vehicle as a control condition. Here's a video of our method.
We simulated an autonomous vehicle by hiding the driver of a regular car. The driver was hidden using a custom-built car seat costume. This gave the car the appearance of a fully autonomous vehicle.
This proportion plot shows the proportion of people who believe the car was autonomous in light gray. This is based on our interviews with the pedestrians after they encountered the vehicle. There are 4 bars here. The left bar is our field study in the Netherlands, followed by the past US field study, followed by 2 Mexico field studies. We compared our Netherlands field study to the US data, which had the highest belief rates, and found no significant difference between the two based on a chi-squared test. Netherlands pedestrians had 83% belief, while US pedestrians believed the car was autonomous 87% of the time. Therefore, we concluded that the hidden driver method was successfully reproduced in the EU. This bar graph compares the looking and crossing times of pedestrians who saw either the autonomous or the normal vehicle. These times were based on 3 coders who calculated each pedestrian's crossing and looking times based on videos of the interactions. The error bars in this graph are 95% confidence intervals. Looking at the light blue bars, pedestrians took longer to cross with the autonomous vehicle compared to the normal vehicle. Looking at the dark blue bars, pedestrians also looked much longer at the autonomous vehicle compared to the normal vehicle. Therefore, we also reproduced pedestrians' atypical behavior with autonomous vehicles in the EU. This bar graph explores group crossing and looking times compared to singleton pedestrian times. Again, the light blue bars are crossing times. We found that groups cross longer compared to singleton pedestrians. The dark blue bars are, again, looking times. We find that groups look longer compared to singleton pedestrians. Interestingly, if we look at how people behave with the normal vehicle compared to the autonomous vehicle, we see an interaction effect. With the autonomous vehicle, for looking times, groups will look longer compared to pedestrians who are alone. When we look at the normal vehicle, however, groups look for a shorter time at the normal vehicle compared to singleton pedestrians. Study 1 was mostly about reproducing the ghostdriver method. Study 2 extended it as an online study. We recruited 101 participants from California and the Netherlands to participate. The study design was a 2x20 between participant study. Participants came from one of two different regions, either California or the Netherlands. And the 20 here refers to the number of videos we used. Here's the same belief graph as we showed from study 1, but with the video belief rates added. As you can see, the proportions of participants who thought the vehicle was autonomous, which is in light gray, are lower for the video samples in both the Netherlands participants and the California participants, compared to the Netherlands or US field studies. So we conclude that online videos of hidden driver vehicles have significantly lower belief rates than on-road vehicles. We also asked people what they noticed about the vehicle in the video study. People said things like, billboard thing on top, not totally stopped, I did not see a driver. When we did a linear regression of whether people noticed each of these different features and whether that predicted their belief rates the car was autonomous, only the feature of no car driver was significant. Viewers were 4.9 times more likely to believe the car was autonomous when they had mentioned that they noticed no car driver versus didn't mention it, but the other car features were not significant. Therefore, we find evidence that no visible driver is a critical feature to give the impression that a car is actually autonomous. Some of the reasons for this are that people would say, when talking about a camera, the sensor could be for any purpose, not just for self-driving. Finally, we asked people how they would feel when seeing the vehicle in the video. Viewers said, scared because it is autonomous and dangerous, wouldn't feel any different, or curious. A regression of whether people mentioned each of these different feelings on the total looking time of the pedestrian in the video found that looking time was related to feelings of concern only. To sum up, we validated the hidden driver vehicle method is reproducible in Europe, and to a less extent online. We also extended the method to show that groups behave differently than singleton pedestrians when encountering an autonomous vehicle. Also, the absent driver is an important cue for conveying the sense that a vehicle is autonomous. And atypical pedestrian behavior is related to feelings of concern or perhaps lack of trust in the vehicle. I'm happy to answer any questions via email, and thank you for your time.